Hello everyone, welcome back to the Blue Team training series brought to you by HackerSploit and Linode. In this video we're going to be taking a look at how to perform disk forensics with Autopsy, and more specifically we'll be exploring the process of how to forensically analyze disks with Autopsy. In terms of what we'll be covering, we'll get an introduction to disk forensics. We'll then take a look at Autopsy and what it is used for. We'll also cover the process of installing Autopsy. Autopsy is cross-platform, which means you can install it on Windows, Linux, etc. And how to perform disk analysis with Autopsy, which again is something that is cross-platform in that you can analyze disk images from other operating systems on a different operating system. So for example, if I'm running Autopsy on Windows, then I can essentially import or analyze a disk image taken from a Linux system, and vice versa. So in that sense, Autopsy is extremely powerful. So the prerequisites for this video are that you need to have a basic familiarity with digital forensics and a basic understanding of Windows file formats, because we're going to be analyzing a Windows disk image. So let's get an introduction to disk forensics. All right, so what is disk forensics? We've talked about memory forensics, which is quite different because within the memory forensics videos, we were dealing with extracting taking a dump of RAM and then analyzing it in order to identify various bits of information. So disk forensics is the process of extracting forensic information from storage mediums like hard drives, USB devices, firmware, etc. Now, in order to forensically analyze a disk, you will typically need to create a forensic image of the drive. Now, with a tool like Autopsy, you can forensically analyze a logical drive that is being used currently, and you don't need to take an image of it, but it's always recommended to take an image of that particular drive or storage medium and then analyze it with Autopsy. So what is a forensic image? A forensic image is an exact digital copy of a physical drive and the data contained within it. So, forensic images can be created through the use of various third-party tools, like, for example, in the case of Windows, we have FTK Imager and the Encase Imager. All right, so forensic imaging tools take an exact copy of a drive without changing or modifying any data, and this is accomplished through the use of a bitstream transfer or a bitstream copy. So if we put ourselves in the perspective of a digital, an incident responder, or someone who is a digital forensic analyst, whenever they're provided with an intrusion or an incident, and let's say a system or computer within a company's network is compromised, well, this is where digital forensics comes into play, whereby you will be required to take essentially create an image, a forensic image of the actual drive, where that operating system is installed, and where any other drives that may contain data. And once you've taken those images, those forensic images, you can then analyze them with a tool like Autopsy to identify what happened. And we'll actually get into some of the features that Autopsy provides to us. So what is Autopsy? Well, Autopsy is a free open source digital forensics tool that can be used to perform forensic analysis on disk images or forensic images. So Autopsy can be used to extract useful information and artifacts from a disk image or forensic image, like deleted files, email messages, browser history and cookies, installed programs, file metadata, and much more. So as I said, when you combine memory forensics and disk forensics, you sort of get a better idea of what's going on. So, in terms of memory forensics, you get useful information like running processes. You also, you're able to dump, command history, as we already explored. And when it comes down to, to actual disk forensics, then we're going to be looking for files with specific extensions, trying to identify any malware. If we do find malware, we can then extract the malware and perform malware analysis on it. We can try and see the actual browser history and where the infection could have come from. So for example, if the user who was using that system downloaded a file or an attachment from a malicious website, then we'll be able to identify that website and, investigate it further. So disk forensics is very important in DFIR, and, Autopsy is used by law enforcement teams worldwide to analyze and extract evidence from hard drives and other storage mediums involved in a crime. So, Autopsy is a very, very powerful tool. Now, in this video, I'll be taking you through the process of installing Autopsy, more specifically on Windows. If you're using it on Linux, Kali Linux already comes with Autopsy installed. However, in my case or in my experience, I've really liked using Autopsy on Windows as opposed to Linux because the performance is much better. However, feel free to use it on whatever operating system you are comfortable with. With that being said, as I said, we'll be going through the process of installing it. I'll also cover, some of the imaging tools like FTK Imager, and we'll then be exploring or taking a look at a sample disk, created by NIST or NIST, depending on how you pronounce it. And they essentially set this up. In this case, we're going to be taking a look at the hacking case image. So they've essentially provided sample disk images to learn more about, disk forensics and, digital forensics in general. So the lab environment is going to be very simple. I just have a Windows system, and then I'll be, walking you through the process of getting everything installed. And then we'll take a look at how to utilize Autopsy. So let's get started. All right, so I'm back on my Windows system. As you can see, this is the system I typically use for, for analysis and also for a bit of malware analysis, in addition to, forensic analysis. So these are the websites that you're going to need to go to. These links will be added as part of a resource to this video. So you can download Autopsy from autopsy.com. So, you can download it for free. And you can actually go through the website here. They have a really, really awesome training. So if you take a look at the training here, they actually provide you with a really cool course. It's about 8 hours, and, you can actually register for that there. Their documentation is also very useful. So if you take a look at the community here, you can see that you have the user guide, and you can learn more about how to utilize Autopsy through that particular guide. So, there we are. There's different versions of Autopsy. In this case, we're going to be utilizing the latest version of Autopsy. So that's the website there. You can just click on download, and you can download it for Windows 64-bit. So we're using version 4.19.3. You can also run it on Linux, as you can see here. And in this case, there we are in OS X 2 as well. So you can download the Autopsy zip file. Linux will need the Sleuth Kit, which I forgot to mention. So that's why I really like running it on Windows, because, in terms of dependencies, there really isn't much. So you can download it without registering here. And you can also take a look at some of the older versions. So once you're done downloading it, I think it's about, it's actually quite large. Let me navigate to where I saved the actual tools here. So under disk forensics, you can see I have Autopsy here. It's about 1.3 gigabytes, and I've already installed it. So it's a very simple installation wizard. Just double click on it and go through the installation process. And then of course we have the FTK Imager, which is used to take images, right? So that's accessible through xtero.com. And you can see you can download FTK Imager. It's a free download here. So quickly assess electronic evidence by obtaining forensic images of computer data without making changes to the original evidence, all with FTK Imager. So once you've downloaded them, you can just go through the setup process. And as you can see, I have them both installed here. So let's get started with FTK Imager, just so that I can walk you through the process of, taking a forensic image. So I'll just open that up. It requires administrative privileges, of course. So we'll give this a couple of seconds. So there we are. This is FTK Imager. So by default, you can click on File, and you can click on Create Disk Image. You can also capture memory, but we are primarily focused on creating a disk image. So I'll click on that there. You can then specify the type or the source of evidence you'd like to you'd like to start off with. So you can specify a physical drive, a logical drive, an image file, the contents of a folder, or multiple CDs or DVDs. So whenever you're going to be taking an image of a compromised system, you're going to be going for a physical drive. So I'll hit next. You can then specify the hard drive right over here. In this case, because I'm running this in VirtualBox, it's going to show me the virtual drive there. So it's about 42 gigs. You can then click on finish. All right, so there's the image source. You can then need to specify the image destination. Now, the image destination will have to be another location apart from the drive you're making the actual forensic image from. So, if I'm taking a forensic image, you'd need to specify another location. So probably another drive, which is why, forensic analysts and, incident responders typically have an external hard drive where they can essentially, copy or save this forensic image. So for the image type, you'll typically be taking a RAW, and that is in the form of a DD. So that's the RAW format, or you'll typically use the E01 format. So, the E01 format essentially stands for the encrypted, or encase file format. So this is typically used nowadays, as it is the industry standard for for essentially storing forensic images. But, you can specify whatever you want and then click on next. You then need to specify the case number because, again, this is a piece of evidence. So, you can specify a case number based on your organization, an evidence number, and then the unique description. So we can say this was taken from Windows 10. The examiner was Alexis, and we can say that, after compromise, or just any notes that might be helpful when we start performing the analysis. So you can then click on next and then the destination folder. So in my case, this is not going to work because I don't have any external drives attached, but you'd specify that destination folder on the external drive. And then you can specify the image file name, including the extension based on, the actual file format you specified there. And then you can also specify the image fragment size. This is typically used. So it's used for RAW, E01 and AFF formats. So you can set that, to maybe 1.5 gigs, and that is going to break it down into multiple multiple pieces. And then, of course, you can also utilize AD encryption to essentially ensure that no one can make changes to this particular disk image and therefore, tamper with the evidence. So that's pretty much it. Once that is done, you click on finish, and it's obviously going to take a while based on the amount of data within the drive you're making an image of. So yeah, that's how to take an image. Fairly simple, right? Okay, so once you've taken or you've essentially made a forensic image, within my downloads folder, I already have the actual NIST directory here where I've downloaded the E01 forensic images here, and I'll just go to the website here. So this is the CFReDS portal set up by NIST for training. So you can see that if you go to home here, it'll essentially give you a description as to what this is. So welcome to the new and improved computer forensics reference dataset portal. This portal is your gateway to documented digital forensic image datasets. These datasets can assist in a variety of tasks, including tool testing, developing familiarity with tool behavior for given tasks, generating practitioner training, and other unforeseen uses that the use of the datasets can devise. Most datasets have a description of the type and the locations of the significant artifacts present in the dataset. There are descriptions and finding aids to help you locate the datasets by the year produced, the author, or by the attributes of the dataset. So all of these datasets produced by NIST to support the computer forensic tool testing and federated testing projects are included here, as well as many other collections. So what this means is that you can browse the latest datasets here, and you can use this to learn disk forensics. And in this case, we're using the popular datasets, which is, of course, the actual hacking case, the infamous hacking case, which again has been used quite a lot to teach people digital forensics. So you can take a look at the actual description here. So on right over here, we can see on September 20th, 2004, a Dell CPI notebook computer, serial number, the serial number is displayed there, was found abandoned along with a wireless PCM CIA card and an external homemade 802.11b antenna. So our job is to sort of analyze this and see what this individual was using this laptop for. As the name suggests, this is a hacking case. So right over here, you have your raw. These are your raw images here. And then you have your E01 format files here. So you need to download both of these, as this is the one we're going to be using. So you can just click on them. They're about 600 megabytes. So about 600 megabytes. And once that is done, you'll need to open up Autopsy. And this is where I'll start explaining Autopsy and how it works. All right, so give that a couple of seconds to start up. And we'll get started by taking a look at how to create a new case. Even though I have a pre-existing case under cases. So under NICE, you can see that's the case there, and that's the one we're going to be using. But before we do that, I need to walk you through the process of creating a new case. So again, the case structure is fairly simple because you're working with evidence, at whatever level you look at it. So you'll need to create a new case just double click on that there. And you'll then be asked to provide your case name. So we can just call this test, and I'm going to save it under the following base directory. So under my user desktop under cases, and the case type is a single user case, and you can then hit next. And you'll then need to provide the case number, so 001, and then the examiner's details. So, you can provide the phone number, email, notes. So the organization analysis is being done for not specified, so you can create organizations, because the great thing about Autopsy is the various collaboration features available to you, and then you can click on finish. You will then be essentially informed, or a dialog box will pop up to essentially ask you to specify the type of data source, right? So the type of data source essentially is referring to what type of disk image you're trying to use. So hosts are used to organize data sources and other data. So you can specify a new host name or generate a new host name based on the data source name. We'll use that option there. Hit next. So this is the data source type. So based on the type of image, or based on the type of image you're trying to analyze, or whether you're dealing with a logical disk, a logical file, unallocated space image file, etc. So you'll typically be dealing with a disk image or a virtual machine file, so you can actually analyze VMDKs. So you can click on that there, and then next, and then this is where you'd specify the path to those image files. In my case, you can see that I've redirected it to that NIST directory under my downloads folder, and then you need to specify the time zone here. So you'll typically, in this case, we'll go for GMT plus 10. And we will say, let's see if I can find that here, GMT plus 10, and we want to use GMT minus 10. So that's, GMT plus 10 ETC, GMT minus 10, and then leave the sector size as is. And once that is done, you can essentially, in this case, it looks like we need to specify the image. So you'll typically specify the E01 image file. So if you click on supported file types, you can see that you can utilize the encase images, which is the E01 format, VMDK images or virtual hard drives, image files themselves, DD images, raw images, so on and so forth. And then click on open, and then next. And this is where you'll have your actual ingests. So let me explain what ingests are. All right, because this is very, very important. So your ingests essentially allow you to perform, different types of functionality. They're essentially used to process, the disk image that you're trying to analyze. So for example, the recent activity, if we click on that there, you can see it extracts recent user activity such as web browsing, etc. And then you have important ones like hash lookup. So this is used to identify a particular file using its hash value. Other important ones are going to be like encryption detection, virtual machine extractor. So if we take a look at that there, encryption detection. So this will look for files with specific or a specified minimum entropy, where you can specify the minimum entropy that you typically associate with encrypted files based on what you're looking for, the minimum size of the file, so on and so forth. Interesting files finder, that's quite useful. So that essentially allows you to identify interesting items as defined by the interesting item rule sets. So you can look for privacy programs, encryption programs, cryptocurrency wallets. That's very, very useful, especially now. and then cloud storage, so on and so forth. So I would typically recommend enabling all of them if you're learning, and you want to make sure that this you specify all files, directories, and unallocated space, because we want to literally analyze everything. So the Plaso, let me see if I can find that there. So the Plaso ingest essentially runs Plaso against a data source. So this one usually takes quite a long time. So I would definitely recommend disabling that. But yeah, for the first time, just enable everything, as it's going to take quite a lot of processing power, especially if the image is quite large. And then just click on next, and that's going to add it. So we're not going to do this because, I've already created a case file. So I'll just close Autopsy here again. And we'll just give that a second to close down. And if we click on cases, you can see we have the test directory and the NIST directory. I'll just delete that there. So I'll just delete that, the test case, and we'll actually open up the NIST case that I'd created before recording this video. So we'll say open a case. And under NIST, you want to make sure you specify the nist.aut, so the autopsy case file extension. So hit open. That's going to open the case database. So give this a couple of seconds. So this is going to take quite a while based on the size of the image and the ingests that you have specified, right? So we'll give this a couple of seconds to a couple of minutes. After it actually opens up, you can see that it's going to provide you with an explorer tree on your left, and I'll explain all of this. So let me just drag that there. As I've said, I've already run all the ingests. During your first run, it's going to take a while. What that means is that I've essentially analyzed, and Autopsy is essentially has essentially analyzed and obtained all the important relevant information. So let me explain this structure here. Now, let me see if I can actually zoom in here. So can I actually modify this? Because previously configure the window, tools, I believe I actually could zoom in. Let me see if I can zoom in here, because I'm not sure you'll be able to see everything. So it doesn't look like I can zoom in, so I'll need to do that in post-processing. With that being said, as said, on your left, you have your actual navigation tree here that essentially, sorts. It essentially sorts all of the extracted data and artifacts, in the form of, as you can see, the data artifacts section here. If I click on that, you can see that it sorts it into communication accounts, email messages, installed programs, metadata, operating system information, so on and so forth. And then, of course, the really juicy stuff is web cookies, web history, and then, of course, the analysis results. You'll actually be provided with, encryption suspected files or programs, extension mismatch detected there, interesting files, keyword hits, web categories, and then of course you have tags here, which I'll get to in a second. So if we take a look at the data sources, this is where you can specify the data source. So in this case, we actually get the name of the computer, so Dell Latitude, and this is the disk image here. So we'll click on the drive there, and you can see we have 3 volumes. We have volume 1, which is unallocated, and then volume 2, which is NTFS, which is where Windows was installed. So that's the default drive. We can click on that there, and you'll then be provided with the listing window here. And at the bottom, you will have the ability to view the data, in terms of hex, the text, application, file metadata, OS account, data artifacts, analysis results, the context, annotations, and other occurrences. So, we can actually go through the Windows, the actual drive here, and you can see that Windows was running here. And of course, given the fact that this disk image was taken in 2004 from the actual dates here, so the last modified time was just before that attack or that hack, when this computer was left unattended. So that's very interesting. And right over here, if you click on this particular column, you have the score. So that indicates whether, as you can see here, that indicates whether the item is interesting or notable. And then, of course, right over here, you have comments, where you can essentially add a comment. If you've found something potentially interesting, and you can always go back to that. And then the number of occurrences of this file or folder. So, for example, if I wanted to right click on this file here, I could add a file tag, so I could say follow up, or I can add a new tag or tag and comment based on, you know, what my requirements are. But I'll actually get into that there. And then, of course, you have the file types. So these are the different views right over here. So you have data sources, file views. So we have file views here. File views essentially provide you with information regarding the file extension that you know, are commonly, you know, being used within this system. So they're sorted by the extension and the MIME type. So by extension, you can see we have images here. So I'll just click on that there, give it a couple of seconds. So these are all the images on the system. So it looks, there we are. So we have PNGs, BMPs, etc. So by extension, the most amount of you know, the most amount of files with a specific extension are images. And then, of course, you have videos here. So these are all potentially interesting for analysis. So let's say you find something that you'd like to essentially analyze. You can essentially right click on it. And for example, this is a video file and you can then extract the file. So I can click on extract to my desktop. Now you have to be very careful with this, because if you're ever analyzing a system that, or a forensic image that was created from a system that was infected with malware, this will most likely infect your system, you know, if you're using the same operating system. So I'll just click on save there, files extracted. And you can see we have that AVI file here. So let's see what this contains. And we'll give this a couple of seconds because we're running Windows. I should have installed VLC on this. That is muted, so you shouldn't actually hear any volume if it, you know, there we are. So it is encoded, so we can't really analyze it there. So we'll just get rid of that file there. But, you know, we can take a look at how to extract an image, just to see that does indeed work. So, you know, we have this particular PNG, and if you click on the actual, on the pane at the bottom, you can see it actually displays the actual application image here. And then, of course, you can view it in text format, where you can view, you know, the actual index text. And then you have the strings here. So it also performs strings analysis, and then your hex editor, which is really, really useful because it tells you, you can analyze the actual stub here and you know, determine if this extension is correct or not. But yeah, you can actually go through them here. So, you know, we can click on this particular image, and we can click on application there. Or in this case, let's see whether we can take a look at this file here. This is a PNG. Those are also PNGs there, but these look like, you know, your just the images included with Windows XP, although some of them might be for other programs. So yeah, that's XP. That looks like a setup image. You know, you actually get the idea here. So it's, you know, you can actually go through all the images there. Audio. So, you know, you have all these audio files there. And, you know, it provides you the modified time, the change time, the access time, the created time. In this case, these look like they've been scrubbed. You then get the size and, you know, the actual location. So if you click on that there, so the file metadata, it'll tell you where this was found. So, you know, these are, the type is carved, and I'll explain what that means here. So for files that have this particular carved files, you know, variable within the actual path or the location, that means that these files were deleted. That's why we don't have you know, the modified time, the change time, and the access time. So, you know, these were, this data is essentially retrieved by the photo recover carver module, which essentially carves files from unallocated space in the data source and then sends the files through the ingest processing chain. And this is typically used to essentially help you discover deleted files or files that used to exist on the system and then were, you know, consequently deleted. So, there we are. So you can actually get an idea of that here. And of course, if you highlight over this, you can actually see that the icons are different, you know, based on the fact that these are carved files here. But, you know, it just gives you an idea as to what was on the system and what was deleted, or, you know, just deleted files in general. You then have archives here. So we can actually see that there are a couple of programs, so like VNC Viewer, and a couple of driver files here. So, you know, we also have Netcat, so we can actually see that this hacker had, you know, the typical tools that you'd expect him to have. And this is actually an old version of Netcat. That's 1.10. We also have John the Ripper, Unix hack. So, all right, interesting. We also have Pandora, very interesting. So, this could potentially tell us what this attacker was doing. So they have a net map, and these are all the archives that they had on their system. And that makes sense because this was a laptop being used by a hacker. And if we take a look at this particular column, you can see that this file looks potentially interesting here, because if we take a look at this particular column, it says right over here that this indicates whether the item is interesting or notable, and we'll actually learn why in a couple of seconds. So that's the actual file views section. You can also go through it by documents. So this is by extension. You can also go through it by documents. So we have HTML documents here. So these look like they were all deleted. Very interesting. It looks like they downloaded it actually displays the content here, but it looks like this individual is downloading documentation on how to use a particular tool, in this case, the Ethereal Network Analyzer. And let's take a look at what else they had here. So it looks like they had some interesting document here that is used to avoid tracking. Very interesting. Let's see what else we can find. Just some downloads here. So this is the Netcat or Nmap page, I believe. I believe it is Nmap, because this is how the Nmap website looks today. I'm not really sure. If we take a look at the additional columns here, we can see the location, the MD5 hash, and the actual MIME type and extension. But yeah, you get the idea. You can actually go through them here. So it looks like we have LSA dump, which again makes sense. So this hacker was actually going through quite a few resources, and then of course we have all of these pages here. So if we take a look at this DNS sniff, LSA dump back again, and then we have this, which looks to be like a server. So that's the Cerberus Internet Scanner. All right, so we're getting an understanding of what's going on here. We then have documents, right, or office documents, if you will. So let's click on this document. You can see that in this case, it looks like this was just documentation regarding, how to use the Brutus tool here. Do we have anything that might look potentially interesting, like this Excel sheet here, which we can actually view the hex here to just see if we can analyze any data from it. So Microsoft Excel worksheet. That makes sense. Let's see, nothing interesting there. And then we have a PowerPoint presentation. We can also take a look at the hex data there, or the hex dump for that particular file, etc., etc. Right, so you can go through the actual file views and go through all the files found on the system based on their extension, whether or not they're documents, whether they're executable, so on and so forth. Looks like we have a couple of PDFs here. So that'll actually display that there. So system scanner. All right, this looks very interesting. So we can actually learn more about what this individual was up to. So as you can tell from this exercise, we're getting to know a lot about the individual that owned this system. And this is what law enforcement does, right? So they'll typically take a forensic image of your hard drive if you have been involved in a crime, hopefully not, and they'll essentially go through it. And I'll get into the interesting stuff that Autopsy will detect. So you have your plain text stuff here, which now is where things start getting interesting, because hackers really like using text documents. But these look like fairly generic. We have word lists or password lists. We also have users. So it looks like he was performing a brute force attack, and we know that Mr. Evil appears to be his name. So yeah, so we can actually analyze there. We then have rich text files, and we can also check for executables here. Now this is as you can see, we can actually utilize the actual column sorting to display the files with that are notable. So for example, we have snitch.exe, user2sid.exe, typical hacking tools and utilities. We also have DLLs, and by the way, you can extract all of those files for further analysis, like if you find a malware executable or ransomware. We then have batch scripts, which obviously will be quite interesting. So let me just sort that here. Nothing noteworthy there, although we would need to perform additional analysis on this. And then of course .com files here. So yeah, you get the idea. We then have by MIME type. So you can go through it by application, audio, image, message, text. So if you click on image here, it looks like we have in this case RFC. So there we are. It looks like we have an email here. So we can actually go through this here. And that is through RFC, and then, yeah, so on and so forth. So these are the file views here. So let me just collapse that there, and then we can click on deleted files. So we can click on deleted files from the file system, and, you know, we can essentially try and find, you know, really interesting files. But these are all temporary files. In some cases, we may be able to get, you know, files that we can recover and analyze. But you know, it just gives us an idea as to what types of files were deleted here by the user on the system. And then you can also sort by, you know, by size, which we'll not get into. So that's file views. We then have data artifacts. This is where things start getting interesting. So it's sorted in based on communication accounts firstly. So it looks like we have emails here. So we can actually see the account type, the ID, that's displayed there, the source path, where it came from, and then the actual artifact. If we click on the metadata here, we get the metadata for that as well. If we click on text here, so you can see this individual said, "Hello, I rather liked your recently posted fping, and I decided to port it to VMS under multinet TCP, TCP IP 3.0. Only some very minor modifications are necessary to run it under VMS 5.5. So it's essentially telling the developer of the tool that he's made changes to it. So interesting stuff there. If we click on text here again, it looks like it's the same email there. And, you know, we can essentially tell where it came from. So, you know, regards per the following email. So, yeah. We then have email messages. And if we click or open that up, you can see we can open that up here, which is pretty much just going to tell us the same thing there. Installed programs, interesting stuff here. So these are all the installed programs when this when this image was taken. So it looks like we have 1, 2, 3, write all stored passwords. Okay, all right, very interesting. An address book, branding. Let's see if we can find any potentially interesting ones here that have been found. Nothing there, so we need to do this manually. So it looks like, you know, we have the typical hacking utilities like WinPCAP, Ethereal Network Scanner. And I know that these tools might be quite old, which is why you might not recognize them, because, you know, 2004, that's quite a long time ago now, you know. And you then have Kane enable anonymizer bar. Okay, very interesting. That's probably a browser extension. Yeah, so install programs. We then have metadata, which we'll get to in a second, and then operating system information. So this is very useful. So the source name, you can see where the source was acquired from. So the source file path came from, you know, the standard system32 config system. And we know that this system is running Microsoft Windows XP, and the date and time here. The owner is Greg Shart, which I can't pronounce correctly. The product ID, the path you get as well. So we now know the owner. So we've been able to identify that. That's something that law enforcement always looks for. So now they find the owner of this Windows XP license. All right, very interesting. So the source file metadata, we can take a look at this here. So that came from the Windows registry. That makes sense. And, you know, we're just given that there. So application, and then we can click on the text here. So, yeah. We know the owner now. And if we take a look at any annotations, we haven't added anything there. So if I found this interesting, I could add a tag. So I could say tag and comment. I could say bookmark, follow up. I could say import, or I could just say owner information here and just click OK. And you can see that there's now a comment here. So I could always go back to that. Recent documents. So these were, you know, documents that were recently accessed based on, you know, time and date. So under D drivers anonymizer, so they were running an anonymizer, IRC, obviously. If we click on the source file metadata, we can actually find where that is stored. And of course, this looks like it's a symbolic link. So yeah, there we are. These are recent files. The run programs, you can actually see that there. And we can also take a look at shell bags here, which I'll actually explain in a couple of seconds. So the shell bags are very, very important. And But before we do that, let's take a look at some of the important aspects here. So like the USB device attached. So that will tell you, the actual USB device here. So it looks like a USB device was inserted with the following device ID. Then we have web bookmarks. So nothing interesting there. Web cookies. This is where things start getting interesting. So we can see that, the Mr.Evil at doubleclick dot whatever. So he has multiple email addresses there. So if we click on that there, you can see this was extracted from Internet Explorer. And if we click on the actual text here, this, because these are cookies, we're essentially accessing the cookie information. And I think in 2004, we still didn't have encryption. So you could get the email and password. So there we are. Then web history. So, this is all the history of all the sites that this individual visited. And of course, we can sort this based on, whether they've any of them have been identified as potentially interesting. And of course, you can also, search through or utilize the keyword search option. So, you can search for specific matches based on your own requirements if you want. But yeah, quite standard browsing history for the time. And then, of course, we have web search. So google.com, as you can see, says, who am I? What's my IP? Who am I, etc. And of course, when this was accessed. That's very, very important in building a profile. You then have the analysis results, right? So that tells you, these are, the files that are likely encrypted because of the entropy specifications that we specified. So under the justification, it tells you that this is a, suspected encryption due to the high entropy. This is a bin file, so, I wouldn't say that it is necessarily encrypted, but, nothing there. You, of course, have the text and the raw hex here, which you can view. Extension mismatch detected. If you hover over that, or, if you actually go through all of these here, you can see that these are files with potentially different extensions that might have been changed. So you can see in this case, the file has the MIME type of application, Microsoft Office. So, this individual might have changed it to avoid detection, which is something a lot of people do. So there we are. And under interesting files, we have a possible zip bomb. So, we can click on properties here. Doesn't tell us much. And if we click on thumbnail, nothing there. So keyword hits, it looks like email addresses there. So files with the hits here, this is the regex that was used, and we can open that up there. And you can see that these are, as it states here, these are all the keyword hits and under email addresses. So probably, in this case, identified a couple of email addresses that might be interesting, regardless of whether they were owned by the individual or, these are addresses that he contacted. And then you have web categories and OS accounts, which is very important. That tells you whether you had other user accounts on the system. So we had Mr.Evil, who looks to be the owner. And of course, if you remember, we were able to identify the name of the individual, the actual legal name. And, we now have his account here. So it'll give you information, and we can tell that he's the administrator because, well, he actually isn't, but the administrator account is. So because of the SID ending with a 500 there. So that's his account, when it was created, the actual scope. And we also have a couple of other ones, which look to be a support account. If we click on this account here, the actual Mr. Evil account, if you click on properties, that'll just provide you with, with information regarding that account. And then, of course, we have tags. So follow up. Let's take a look at the owner here. So the actual comment, that we specified, this is owner information. We know that the owner, we should probably look into that individual. So, this is how much information can be gathered from an individual's computer, just to show you that. And of course, this is a very simple case. As I said, this disk image was taken in 2004. So now that we've taken a look at all of the information that was extracted, let's explore something a little bit more interesting. Now, as I said, you can also export different types of files. So for example, if I wanted to export all of these email addresses, I could click on that there, right over here, and say save table as CSV desktop. And, I can probably provide it with a better name here instead of using all the rejects there. Let's see, can I actually rename this here? We could just say emails .csv, save it, and it's going to save that. And of course, I think we can actually view it with Notepad++. We'll give that a couple of seconds to open up. And there we are. So, we can export all the useful information, and that's typically going to be very useful. And you can do that, for all, files that you'd like to analyze later. However, as I said, be very careful with that. So yeah, that's how to extract files. As I said, you can also go through the deleted files and, the extracted content, keyword hits. Now let's take a look at the timeline, because this is very important. You can also take a look at, images and videos to sort through. So this will essentially display all the, videos and images found on that system. And you can go through and analyze that. And I'll just close that up there. We can take a look at communications first. But this shows you all official communication. So you can see it looks like this individual was a user or a student at Stanford, because they have a stanford.edu email, or at least someone, you can see that's where, no, it doesn't look like they are. So these are found within README files of specific tools. So they were likely developers of the tools. And then, of course, you can go through that and analyze all communication there and apply specific filters based on your requirements. We then have geolocation. So this will try and, identify geolocation based on images or any metadata found within files. Now, in 2004, cameras really didn't have that capability, or not yet. And then, of course, we have the timeline here. So we'll give that a couple of seconds, and we can actually go through the timeline. So I'll explain what this is used for. So the timeline tab or feature allows you to essentially get information regarding the usage of the system in a sort of in a detailed way that you can actually click on counts, details, or either the list format. So the list there, so that gives you the actual usage in sort of like a Gantt chart format, whereby you have the start date here, and you can actually see what they did moving, or actually getting closer to the actual attack. So I can actually drag that back all the way to maybe like 1997, or drag it back all the way to the actual event itself. And I can say, let's see, if I wanted to see what the individual was doing, maybe from 2002 to 2000 and, to the latest, you can actually see that here. So you can then click on any of these here, and you can actually see what was going on. And let's see if we can actually customize or use a filter to make sense of this. So in this particular case, if we click on list here, and I'll just keep the timeline quite short here, but you can actually see that the event type in this case here, if we highlight over it, it should actually display. So file was modified. It'll tell you when it was modified. So you get an idea of what was going on from the year 2000 all the way to whatever date or range you specify. Or, in this case, we could actually bring it closer to the actual date of the event. So let's bring that here. So yeah, from 2003 all the way to 2004, it looks like there's very little activity going on, in regards to, we can see that this file was added, it looks like. So file accessed, sorry, not added. File modified, this looks like it was modified as well. So, yeah, you can use the timeline to analyze that type of activity. And then, of course, you can click on the Discovery tab here. So the Discovery tab allows you to essentially find, different types of files using different filters. So you can look for images, videos, documents based on your own parameters or requirements. So, we can click on, for example, documents and specify their file size, the data source, where they're coming from, the past occurrences. You can also, click on interesting items, the parent folder, so on and so forth. So you can actually classify it based on your own requirements. You can do the same for domains. And yeah, and of course, once you're done, you can click on Generate Report, and you can generate an HTML report. You can also generate an Excel report, or store it in any of the other formats. So in this case, what we can try and do now is we can actually, generate a simple HTML report. So we'll just call this, let's see, what was the original name of the analysis? This was a hacking case. So we'll just say hacking case 2004. And the footer, we can say hacking case, NIST hacking case, or, whatever works for you. 2004. You then click on next, specify the actual data source there, next, and then all results or all tagged results. So in this case, if you've tagged a lot of information and you've made comments about interesting things, then you typically want to only specify your tagged results. In this case, we'll just say all the results and click finish. That's going to generate the HTML report. It's going to take a while because of the amount of data, and we'll give this a couple of seconds. All right, so once that is done, we can click on close there. And if we take a look at the directory where it saved it under cases and NIST, we also have the export there. Sorry, not export, we have reports. There's the report there, and then we can click on the HTML page. That'll open it up. We can open it up in Firefox. There we are. And we'll give that a couple of seconds, and there we go. So, if you would have added more comments regarding interesting files or information, then you'd be able to, only have that information displayed. But, it displays the case number, the examiner, image information, the software information in regards to, what system was used to perform this analysis. And then you can click on the case summary, which is displayed here, and you can you can take a look at for example, in this case, the tagged results here, and that might be useful there. So in this case, we tagged the actual owner information there, so that is displayed there. We then have interesting files, which is displayed there. We can go through all of the actual extracted artifacts and also the reports generated. So we have all the programs here. So this is very useful, especially for law enforcement. And as you can see, this is how to use Autopsy. So with that being said, that is going to conclude the practical demonstration side of this video. So thank you very much for watching. If you have any questions or issues, you can check the Autopsy documentation page. I definitely recommend taking a look at some of the other sample data sets or images, to learn how to use these tools. Most of these challenges or data sets usually have questions that you need to answer. So you need to analyze, all of the artifacts to identify that information. I just went through it, and, I was just taking you through it as a beginner, whereby, we found a little bit of information like the user accounts, the owner of the Windows license, and, quite a bit of other information. So yeah, digital forensics, and more specifically disk forensics, goes much deeper than what I've done. As I said, if you're new to Autopsy, then this is a great starting point. With that being said, in the next video we'll be taking a look at Docker image analysis with Trivi. So I'll be seeing you in the next video.